Okay, this is Techmath1. We're looking at review 1. This is on chapters 1 and 2. And we're looking at the review. This review can be found in your packet, in your homework packet that you bought. It's after all of the homework assignments. They have, I also posted a blank in case some of you don't have your books yet. It says Techmath1, chapter 1 and 2 review. It's after all of the homework assignments. All right, so let's take a look. First things first, knowing our stuff. Do we know what a whole number is? Whole numbers are 0, 1, 2, 3, 4, and so on. So we're looking for whole numbers here. That is not. That's less than 0. Whole numbers set doesn't have negatives in it. Not a whole number, not a whole number, not a whole number. Oh, square root of 49 actually is a whole number. That's 7. We'll put it down as the square root of 49, no? And 30 is a whole number. So two numbers in that set. Rational numbers are numbers that can be expressed as the division of two numbers, or fractional, rational, fractional. So look, -5 over 1 is a fraction. So 2/3 is a fraction. Square root of 3 is not. That is a non-terminating, non-repeating decimal, so that one doesn't get to play in the rational number list. 2.7 is actually rational. That's 27 over 10. Square root of 49, of course, is. That's 7 over 1. And 30 is. That's 30 over 1. 1, 2, 3, 4, 5 of them for that. Irrational are non-terminating, non-repeating decimals. So the only one that fits the bill there is the square root of 3. Is irrational. All right. Non-terminating, non-repeating decimal. This is a repeating decimal. That's 0.666666 forever, but it's got a pattern to it. So that isn't irrational. That's rational. It can be expressed as the division of two numbers. Okay, so now identify the properties. So look, when I have 5 plus -9 equals -9 plus 5, when I only have two things and I just change the order in which they're written, that's called the commutative property. Commutative. And that's actually the commutative property of addition. This one is multiply 2 times 3 times 5, and they have parentheses around the 2 times 3, so that would be first, is the same as 2 times 3 times 5. So that means you do 3 times 5 first and then double it. When there's 3 or more numbers, that's called the associative property. Associative property. And that is of multiplication. And then what about 12 plus 0 equals 12? Well, look, addition happened there, but I ended up with what I started with. I started with 12, I ended up with 12. And so that's called the identity property of addition. All right. Let's take a look at this. Add up the numbers. So -9 plus 13, that's +4, plus -3, that's +1. 3/10, 2 negatives in a row, make it a plus 5/6. And now we have to find the common denominator between 10 and 6. I need a common point of reference there. So I take 10 and I break that down into 2 times 5. I take 6 and break that down into 2 times 3. And now to find the LCD, the lowest common denominator, I first take what they have in common, and then I take all the leftovers. Oh, here, I'm going to turn that off. That's distracting. All right. So we got 10 times 3, that's 30. Now, some of you probably didn't even have to do that. You just thought of what is the smallest number that 10 goes into, that 6 also goes into, and that answer would be 30. So that's a 30, that's a 30. And now you think to yourself, how did I get there? How did I get from 6 to 30? I multiplied that by 5, so I have to do that on the top. That's 25. I multiply that by 3, so I have to do that on the top. That's 9. And so now 9 plus 25 is 34 30ths. Oh, but I'm still not done, because now I can reduce. Those are both even numbers. So I divide by 2, and I end up with 17/15. for my final answer. Whew. So that's why a lot of us don't really like working with fractions because, you know, lots of steps. All right, so multiply. There's two ways you can multiply fractions. You can just do numerator times numerator, denominator times denominator, and reduce. That's a way. Negative 18 over 30. And now I reduce that. 6 goes into both of those. So divide by 6, and I end up with negative 3/5. That's one way to do it. Another way to do that same problem is to cancel numbers off. You like pre-reduce it. You reduce it first and then just multiply what's left. So here's number 9 again, just in a slightly different way. 9/10. So I got negative 2 times 3 times 3 on the top. 9 is 3 times 3. And 3 times 2 times 5 on the bottom. So I broke them down into primes just so it would be easier to see what gets picked off. So the 3's get picked off, the 2, but there's a negative there, so the negative 1 stays. So negative 1 times 3 is negative 3, and 5 on the bottom. 1 basically times 5. Different way of doing it. There's a third variation on that you probably learned just to save room, where maybe you went like this, like 3 into 9 3 times, 2 into 10 5 times. Don't forget the negative, and then negative 3/5 that way. That's fine too. You can do it that way. You really just did this method, just with a little different shorthand. All right. Awesome. Let's look at number 10. We'll finish off page 1 here. So we got negative 8/7 divided by negative 2. Oh, that's interesting. 11. 3. Oh, wait, you know what? Let's put 11 over here. 3 to the 4th times 3 to the negative 2 times 3. 12 is 6 to the 0 power and the negative 3 power. 13 is 7 to the negative 2, 7 to the negative 3. 14 is 2 to the negative 3rd power raised to the 4th power. And 15 is 3.61 times 10 to the negative 3. All right, so let's take a look at these. So first, this one. Physics people do this all the time where they write like fractions over fractions. Math people would have written it like this. That's what's going on there. That is negative 8/7 divided by negative 2. So I just wrote it with a divided by symbol. Remember, we never divide fractions. We multiply by the reciprocal. So negative 8/7 times negative 1/2. Negative times negative is a positive. 7 times 2 is 14. And then I can reduce it. So 4/7 is it. All right. These are all just different rules of exponents. So remember, when there's nothing there, there's a 1 there. When I have light bases like that, I can add up the exponents. So 4 plus negative 2 plus 1. So that would be, what is that? 2 plus 1 is 3. 3 to the 3rd. Anything to the 0 power is 1. So this is 1 to the negative 3. Negatives, just move it into the denominator, but that's really not going to do much for this because that's just going to be 1 over 1 to the 3rd. Well, think about what 1 to the 3rd is. That's 1 times 1 times 1. This is 1. So I got 1 divided by 1. And that is just plain old 1. All right. This one, again, the negative exponents don't do anything but change the position in the fraction, just like how that pulled it down to the bottom. What would happen here is this would get shifted up to the top. That would get shifted down to the bottom. And now I would just cancel them. Remember what this is shorthand for. That's 7 times 7 times 7. That's 7 times 7. They cancel 1 for 1. There's 1 7 left on the top. Or if you want to use the rules of exponents, that's 3 minus 2, which is 7 to the 1st, which we don't really put the 1 there ever. we just say 7. All right, when you have a power raised to a power, you multiply. And again, this text doesn't really care if you leave it negative. So you could leave it like that. That would be fine. If you want to, like in algebra class, where we get all uppity about that, where we would want you to move it down. They always add that little thing in algebra that you're not allowed to have negative exponents. And so then you have to always express it as a positive, which means that negative moved to the bottom. And then you drop the negative. Scientific notation, when it's times 10 to the negative 3, that's moving it, the decimal, to the left 3 places. So 1, 2, 3. Now, mind you, that isn't adding 3 zeros. It only added 2 zeros. And don't forget about the 6-1. That gets overlooked a lot more than you would think. So don't truncate the number. You know, people focus about these zeros and then they forget about the rest of the number. Make sure you write the whole thing down. All right, let's see how much time we got. Okay, cool. That's page 1. Next video will be review page 2.